All right, hi folks, this is Larry Maslino. I'm recording a video for STAT211. This is the chapter 12 homework, and this introduces the idea of hypothesis testing. So let's read this over. It says, a friend of yours claims to be psychic, but you're skeptical. To test this, you take a stack of 100 playing cards, and you have your friends try to identify the suit: hearts, diamonds, clubs, or spades. What is the null hypothesis? Well, whenever you're setting up a hypothesis test, the first step is to start out writing out what's called the null hypothesis and the alternative hypothesis. Now, the null hypothesis is labeled as H naught. The alternative is labeled as H sub A. And then we have to indicate whether we're testing a proportion. For that, we're going to use the letter P, or a mean. For the mean, we're going to use the Greek symbol sigma. In this example, we're testing the proportion of cards that are a certain suit. So I'm going to write this as P for the null and alternative. The null is always written with an equal sign. And in this case, I'm going to use the fraction 1/4. The reason 1/4 is we're trying to pick the suit, and you have a 1 out of 4 chance of getting that correct. Now, when you go to write the alternative, you have 1 of 3 choices for the math symbol. When you go to type in the math symbol here in this box, it can either be a not equal symbol, or a less than symbol, or a greater than symbol. So how will you know whether to use a not equals, a less than, or a greater than? Well, that comes from reading the problem carefully and translating a phrase in the problem into one of these 3 math symbols. I'll show you that in an example in just a minute. In this example, they really just asked us to come up with the null hypothesis. So our null hypothesis is P equals 1/4. So here's the answer for this null hypothesis. Okay. All right, let's do another example where we're interested to kind of walk through all of the steps of the hypothesis testing methods. Let's take a look at this one. So this question is going to have multiple steps to it. It says, according to a recent census, 18% of people in the United States are Hispanic origin. One county supervisor thinks her county is different proportions. So she takes a survey of 479 residents and finds 45 are Hispanic. Part A, state the hypothesis. And they say the proportion of people in the county that are Hispanic is going to be denoted by P. Well, this is going to be a hypothesis test for a proportion P. So let's start writing it out. Here is the null and alternative. I'm going to use a P because we're dealing with proportions here. The null always gets an equal sign. And what we're really trying to test is the claim that 18% of people are Hispanic origin. So I'm going to write that as 0.1. The alternative is also going to use the number 0.18. The number always stays the same between the null and alternative. But what I have to figure out now is, what math symbol should I put here? I have a choice of either a not equals, or a less than, or a greater than. Well, I'm going to come to the wording of the problem, and I'm noticing this supervisor thinks her county is different. Well, the word different implies not equals. So I'm going to make this a not equal symbol here for the alternative. Well, if you notice, and that's answer A for this multiple choice question. And we call this a one proportion z-test. It's one proportion because we're working with proportions and we just took one sample. And the reason it's a z-test is, behind the scenes, we're going to use the normal distribution to conduct this hypothesis test. And the normal distribution is labeled as a z-test. All right, let's go to the next part. The next part says, check the appropriate conditions. Well, the 2 conditions we have to check here is, we want the sample size to be less than 10% of the population size. And if we take n times the proportion used in the null hypothesis, we write that as n times p0. We want that to be at least 10, greater than 10. And n times q0 is greater than 10 also. q0 is just 1 minus p0. In our example, p0 is 0.18 for us. All right, so let's do the check. In our case, the sample size n is 479. So I'm going to work out 479 times 0.18 on my calculator. And if I do that, I'm getting 86.2. All right, let's do n times q0. That's the other check. Well, q0 is 1 minus p0. Well, that's 1 minus 0.18. So that's 0.72. So this is going to be 479 times 0.72. And if I work that out on my calculator, I'm getting 344. I'm sorry, it's 0.82. My mistake here. This should be 0.82. Whoops. So this is 0.82. So 479 times 0.82 is 392.8. So the conditions to proceed with this hypothesis have been met. So that's this answer here. All right, so the conditions are met. It's appropriate to use this normal distribution to perform the hypothesis. All right, well, here's what we're going to do now. We're going to calculate what's called a test statistic, and we're going to superimpose it on this normal distribution. And then we're going to find the area and the tails of the distribution. That's going to be the p-value. All right. Well, first thing is, let's figure out which one of these curves is appropriate here. Well, what I want to do is first identify the mean of this distribution. Well, the mean is going to be 0.18. So here is the mean of 0.18. This mean is not right because this mean is 0.94. That tells me this is wrong. This mean is 0.94. That tells me this is wrong. So it must be answer A. All right. The next questions are going to ask us to calculate two numbers, a test statistic and a p-value. Now, a test statistic is really like a z-score that represents the sample data. So I'm going to take the sample data and create a z-score out of it. I want to let StatCrunch do this because this is kind of a messy calculation. So I'm going to let StatCrunch do it. The same thing for the p-value. The p-value is the probability of observing the sample data that you did under the conditions that the null hypothesis is assumed to be true. Let's calculate the proportion for the sample here. So the sample proportion of Hispanic people, according to this, is 45 out of 479. Well, I'm going to work that out on my calculator. And that works out to be 0.094, 9%. Well, that's very different than the 18% we were expecting to see. Right? If 18% of the people in the United States are Hispanic, we would expect this county to be about 18%, but it's only about 9%. All right. So the question is going to be, what's the probability that you observe 9% Hispanic people in this county if you assume that the true population proportion is 18%? Well, it's going to be a low probability, right? It would be very unusual for you to observe only 9% in this county if the true proportion was really 18%. So we're going to expect the p-value to be a pretty small number because it would be very unusual to observe the sample data that we did. All right, well, for this, I'm going to go to StatCrunch. So let me come down here to the menu and open up StatCrunch. I'll do this side by side here. Okay. Well, if you want to run a hypothesis test for a proportion, it turns out you can use the same command. So this is a hypothesis test for a one sample proportion test. Well, if you remember when you were working with confidence intervals back in module 7, you used a command that was stat proportion stats, one sample with summary. All right, so that's what we're going to do. I'm going to go up to stat proportion stats, one sample with summary. Okay, so the first thing they're asking us, what's the number of successes? Well, in our example, that was the 45 Hispanic people in our sample. What's the number of observations? Well, this is our sample size, 479. And notice I'm going to check this box here that says hypothesis test. And now what I have to do is mimic the setup of the null and alternative. Remember, here was our setup. So I'm going to put a 0.18 in this box. And notice in this drop-down menu, I can pick from any of the 3 possible options for the alternative. It's either a not equals or a less than or a greater than. Well, in our example, we're using not equals, so I'm going to leave that as not equals. And now I'm just going to click compute. All right. Well, if you notice, here's the test statistic. So here is the test statistic. It's called Z-stat. It's negative 4.9. And here's the p-value. Now, the p-value here is shown as less than 0.001. That's StatCrunch's way of telling you the p-value is essentially 0. It's so small that it's a number less than 0.001. So our answer here is 0. Well, if the p-value is low, and usually by low we mean less than 0.05, when that happens, you reject the null hypothesis. Remember, our null hypothesis was that the proportion of Hispanic people is 0.18. Well, the reason we're going to reject this is in our sample data, the sample data was not consistent with 18% Hispanic, right? Our sample data was only 9% Hispanic. By the way, here is the sample proportion worked out, right? It was only about 9%. So that gives us evidence that here it is, the p-value is low. There's evidence that the Hispanic population in this county differs from that as the nation of a whole. Yeah, because our sample data was about 9%. The null hypothesis said it should be about 18%, very different. So it led to a very low p-value here. Okay, folks, so you can see StatCrunch is going to help you out by giving you the test statistic and the p-value automatically. All right, let's do another example. Okay, let's take a look at this one. All right, it says, according to a recent census, 17.4% of housing units are vacant. County supervisor wonders if her county is different. So she took a sample of 903 and finds 190 of them are vacant. All right, so again, let's set up the null and alternative. The null is that the housing units have a 17.4% vacancy. And again, the wording here is different. Well, different means use a not equal symbol in the alternative. So here is the setup for the null and alternative. Again, this is a one proportion z-test again. Let me scroll down. We're going to check the requirements again. So in this case, we're going to take n times p0. Our sample size here is 903. The proportion of vacancies we say is 0.174. So if you work this out on your calculator, you get 157.1. Here it is. If you work out n times Q0 here is 1 minus 0.174, which is 0.826, I think. Yep, I think that's right. So n times Q0 is going to be 903 times 0.826. That works out to be 745.9. Remember, we're making sure that both of those answers are more than 10, which they are. Okay, so the conditions here are met, and it's appropriate to use the normal distribution. Okay, let's go down to the next section. It wants to know which one of these normal curves is appropriate. Well, the mean should be the same as 0.174. So only this middle diagram here has the mean 0.174. So that means that's correct. We need the test statistic and the p-value. So let's go back to StatCrunch. The command to use is stat proportion stats, one sample with some. In our case, the number of successes, that means the number of vacant units, was 190. The sample size was 903. And now, again, I'm going to copy the null and alternative here. For us, it was 0.174. And the alternative was a not equals. So this is my setup. I'm going to click compute. And here's the test statistic. Looks like it's 2.89. Here is the p-value, 0.004. Well, if the p-value is a low number, and usually we use less than 0.05 as a kind of a default value, then you should reject the null hypothesis. Our null hypothesis was that the proportion of vacant units is 17.4%. But notice in our results, we had the vacancy as 21%. So our conclusion in all of this then is, if we reject the null hypothesis, because the p-value is low, there's evidence that the proportion of housing units that are vacant in this county differs from that in the country as a whole. Yeah, so the 17.4% that was claimed is different than what we observed, which was about 21%. All right. Folks, let me do maybe one more example here. And this is to give you practice in setting up that null and alternative hypothesis. Okay. All right, well, it says here, we think 34% of CEOs had MBAs. Well, I'm going to write that as P equals 0.34. The question is, what symbol do you use for the alternative? Well, notice they say percent. Has the percentage changed? Well, change is really different. So it's going to be not equal 0.34. So again, we're focusing on the word changed, meaning different. Let's go to example B. 21% of cars need transmission work. The manufacturer hopes a redesign has solved this problem. Well, the null hypothesis is going to be that the proportion of cars that need new transmissions is 0.21. The manufacturer is hoping that the redesign has improved. Well, improved would really mean less than 0.21. Let's go down to the bottom one. Market researcher decides to test a new flavor soft drink, and he wants to be sure that over 52% like the flavor. Well, the null is going to be P equals 0.52. Over 52% implies a greater than sign. So the alternative here is going to include a greater than sign. So again, to figure out the null and alternative, remember the null always has an equal symbol in it. The alternative is either going to have, a not equals or a less than or greater than. You have to figure out which is the correct choice based on the wording in the problem you're dealing with. All right, folks, hope this is helpful as you're working in the Chapter 12 homework.